All right, section 2-3, using Venn diagrams to study set operations. First thing is first, what is a Venn diagram? Well, if you go back to the first grade, a Venn diagram is two or more circles that can overlap with each other, and those circles represent sets. Sometimes the circles won't overlap because they'll have nothing in common, and we call those disjointed sets. What we're going to do is we're going to go over the basics on a Venn diagram and then work our way up. And we're going to also need to bring over the set operations that we learned in section 2-2. For this first question, which is question number 13, it wants us to construct a Venn diagram. And it gives us the universal set, which are whole numbers from 0 to 9, and it gives us subsets A, B, and C. So let's go ahead and construct our Venn diagram. Because we have three circles in this case, three subsets, we must have three circles, and the circles must overlap with each other. Now, I can't draw circles to save my life, so don't judge my circles. Okay. So the first circle is going to be for set A. The second circle is going to be for set B. You know what? I should start labeling these, and let me draw this one a little bit better. A, B, and the last one is going to be set C. Okay. So they're not proportional. And after that, you're going to draw a box around your circles. And this box represents the universal set. So we're going to try this again with our box, because I'm definitely going to get this down pat. All right. So I'm going to put a little U on the side. And all of the numbers in the universal set must fit inside of our Venn diagram somewhere. Okay. Let's look at our subsets. And the first thing that we're going to do is we want to find an element that all three sets have in common with each other. If you notice, all three sets have a 0 in common. Let's double check to make sure that's correct. Yes, all three sets have a 0 in common. So that means we're going to put a 0 in the middle, because 0 is inside of set A, set B, and set C. Once we do that, let's cross out this 0, because we know it already been placed. Now let's look at set A and set B. And besides 0 that we crossed out, what other elements are in common between set A and set B? As you can see, there is an 8 in common between those two sets. So 8 is inside of A and it's inside of B, but if you notice, 8 is not inside of C. So we're going to put this 8 right here. It's in A, it's in B, but it's not in C. Let's cross that out. Let's look between set A and set C now. Let's change the color of my highlighter as well. Between A and C, they have a common element of 6 and also of 4. So the elements that are at A and C, but not in B, is going to be 4 and 6. Let's look at the common elements between set B and set C. Set B and set C have a common element of 9. So I'm going to put a 9 right here inside of set B and C, but it's not in A. Okay. Now, the only element that is left in set A is 2. So this is for A only. Let's also cross out our 9. Let's get rid of our 2. For B only, there's only a 3. For C only, there's a 1, and then there's a 5. And as you can see, there's only one number that has not been placed. In our universal set, every other number has been placed except for 7. So 7 is a part of the universal set, but is not in A, nor B, nor C. So 7 goes outside the circles in the box. And that is how you construct your Venn diagram. All right, guys. I'll catch you in the next one. Take care.